Today, we're diving into something super cool. We are exploring the invisible, yet incredibly powerful mechanics that govern literally every moving object around us. We're going to break down the core mechanics of linear momentum to see exactly how it dictates everything in our world, from a simple game of sports all the way up to space exploration.
Okay, let's dive into this with a fascinating physics mystery. Picture this for a second. Imagine you're standing in front of a bicycle that's rolling toward you at 10 miles an hour. Now imagine a massive heavy truck rolling toward you at that exact same speed. Even though their speed is completely 100% identical, you inherently know that the truck is going to be significantly harder to stop than the bicycle, right? But why is that? Why doesn't speed alone determine how hard it is to stop a moving object? Well, the answer to that question unlocks one of the most absolutely crucial concepts in all of mechanics and engineering. To solve this mystery, we need to transition into the formal science that gives us the vocabulary to really answer that truck versus bicycle question.
So, let's get into Section 1, Defining Linear Momentum. What we're really talking about here is linear momentum. And the simplest, most accurate definition of linear momentum is that it is the quantity of motion an object has. I want you to really think about that phrase for a second. Quantity of motion. Motion isn't just about how fast something is traveling. Motion actually has a measurable amount. It's a physical quantity that an object actively possesses while it's moving. Let's look at the math and see how this builds into a mathematical certainty.
It all comes down to a beautifully simple universal formula. P equals m times v. That's it. It relies entirely on just two variables. Let's break that down. The P stands for momentum, the m stands for the mass of the object, which we measure in kilograms, and the v stands for velocity, which is measured in meters per second. So when you multiply the mass of an object by its velocity, boom, you get its total linear momentum. And because we're multiplying kilograms by meters per second, the official standard SI unit for momentum is exactly that, the kilogram meter per second. It's a direct, proportional relationship. Your quantity of motion depends entirely on how much stuff is moving, that's your mass, and how fast that stuff is moving, your velocity.
Moving on to Section 2, the football thought experiment. Now, what's really interesting about this slide is how we can use it to set up a controlled thought experiment to visually isolate our two variables. Let's isolate mass first. Imagine two footballs flying through the air right at you. We've got a heavy football and a remarkably light football, and both are moving at the exact same speed. If you had to catch one, which one would be harder to stop? Just like our truck and bicycle example earlier, the heavier ball is going to hit your hands with a lot more force. It has greater momentum simply because it has more mass. So when velocity is perfectly equal, the heavier mass dictates a greater quantity of motion.
And this brilliantly illustrates the other side of the equation. Let's look at the velocity variable. Now we're comparing a slow football and a fast football. And this time, they both have the exact same mass. They weigh exactly the same. If the mass is identical, the football that is moving really fast is going to be far harder to stop than the one just sort of drifting slowly through the air. By isolating the velocity, we can clearly see that increasing the speed directly and undeniably increases the momentum.
So, to summarize our little thought experiment, the rule is incredibly straightforward. Momentum increases when either mass or velocity increases. You essentially have two levers you can pull here. If you scale up the mass, the momentum scales up. If you scale up the velocity, the momentum scales up. It's this perfect balancing act between how heavy an object is and how fast it's going.
Let's look at Section 3, Real-World Applications. Now that we totally get the mechanics, let's escalate the stakes a bit. We're moving from throwing footballs to looking at high-stakes mechanics and engineering, where this exact formula actively shapes our modern world. Linear momentum governs countless everyday situations, and understanding it allows us to manipulate those situations to our advantage. First off, consider a cricket player. When they're catching a blistering fastball, they naturally move their hands backward while making the catch. Why? Well, they're dealing with an object that has a high velocity and therefore high momentum. By moving their hands backward, they're actually managing that massive quantity of motion. They're changing how that momentum is absorbed over time to keep the ball from just bouncing right out of their hands or, injuring them. Second, think about airbags in our cars. In an accident, a human body has a high quantity of motion, a lot of momentum. Airbags are specifically engineered to reduce injuries by interacting with that exact momentum. They slow down the velocity safely rather than allowing an instantaneous, highly dangerous stop. And third, it scales all the way up to literal rocket science. Rockets are able to move forward specifically by pushing gases backward. This is linear momentum in action on a massive scale. then manipulating the mass and velocity of expelled gases to generate the momentum needed to push a heavy rocket all the way into space. So, from a simple game of sports to automotive safety, right up to space exploration, linear momentum is one of the most important concepts in all of engineering.
Section 4. The final takeaway. So the crucial point is how all these elements come together to define the physical world.
Let's bring all these ideas together and quickly recap our core takeaways. First, remember the definition. Linear momentum is the quantity of motion. Second, it depends entirely on just two factors, an object's mass and its velocity. Third, our foundational formula is simply P equals mv. Fourth, because of that formula, we measure it using the SI unit of kilogram-meter per second. And finally, the golden rule. Greater mass or greater velocity always means greater momentum. These are the absolute fundamentals of how moving objects behave. Which brings us to a final thought for you to chew on. Knowing that absolutely everything moving around you possesses a specific, calculable quantity of motion, what heavy or fast-moving forces in your everyday life are you going to view entirely differently now? Whether it's the cars on the highway, the wind blowing against your house, or just tossing a ball with a friend, you are constantly witnessing the elegant, invisible mechanics of linear momentum at play. Thank you so much for joining me for this explainer, and keep looking for the science in the world around you.